All right, so to continue the lesson, we are going to be talking about dividing with radicals. So a radical cannot be in the denominator of a fraction. So if this happens, we have to rationalize the denominator. And we do this by multiplying by something so the radical can be simplified. So just to start with, as a way to practice of what to pick to multiply, we have some examples. So if we're trying to get rid of a square root, that means that we are creating a perfect square. So for this one, this has a power of 1, and again, we don't write it on the outside, but this is a 2 for the root. So when I'm multiplying, I have to create something so that I can take the square root of it. So for variables, that means that our power has to be divisible by 2. So for this, if I multiply by x to the first, that would give us the square root of x squared, which we can simplify then to be x. So our radical completely simplifies. Same thing with a number. So again, we're taking a square root. So if you have your list of numbers somewhere, we always start with the smallest. So again, we're looking at these numbers. We have to decide if we can take 2 times something to get 4, which we can multiply by 2. So in this one, if we multiply by the square root of 2, square root of 2 times the square root of 2 is the square root of 4, which we would then simplify to be 2. And then if we're doing a cubed root, so we have to create a perfect cube. So again, I'm going to look down this list. So, and we always start with the smallest number. So can we take something times 9 to get 8? And the answer to that is no. And then can we take something times 9 to get 27? And the answer to that is yes, so we can multiply by 3. So for this one, if I'm trying to rationalize, we're going to multiply by the cubed root of 3. So when we do that, that is the cubed root of 27, which we can then simplify to be 3. So again, our radical completely simplifies. And same thing with variables. So again, we're going to multiply by the cubed root of, and then for exponents, they have to add to be 3. So we already have a 1 here. So that means that I need to have an x squared in this one. So again, now when we multiply, we'll have the cubed root of x cubed, which we can then simplify to be x to the first. Okay, so we're going to use that idea to help us rationalize if we need to. So again, when we're dealing with fractions, we still want to check to see if we have the same roots and if we can simplify the fractions before we rationalize. So on problem 10, there's no way to simplify 2 divided by 3. So that means that I'm rationalizing this denominator. So we're trying to create a perfect square. So that means I'm going to multiply this by the square root of 3. And whenever we multiply to the denominator, we have to multiply the same thing to the numerator. And then we just simplify as much as we can. So 2 times 3 is 6. So in the numerator, this will be the square root of 6. And then 3 times 3 is 9. So we'll have the square root of 9. We can't simplify the square root of 6 anymore, so that's going to stay the same. And then the square root of 9 is 3. So this is the final simplified answer. All right, next one, so same thing. So we have square roots. On this one, we can simplify our fraction because we have a x cubed in the numerator and an x in the denominator. So if we simplify those, we can subtract those exponents. So in the numerator, we'll have the square root of x squared over the square root of 5y. And so again, we can't have that radical in the denominator. So this time, we have to create a perfect square for both the number and a variable. So if we take 5 times 5, that'll be 25. And then y times itself, so our exponents will add to be 2. And again, we just simplify as much as we can. So if we're looking at this, notice how we already have an x squared. So we can simplify that just to be an x. And then there's no way to simplify that. So that'll be just the square root of 5y. And then in our denominator, that will give us the square root of 25y squared. So again, this can be simplified. So our final answer is going to be x square root of 5y divided by 5y. All right, in 12, this time we need to create a perfect cube. And we can't simplify the fraction at all because we don't have the same variables, and 5 and 7 don't have a common factor. So again, this time we are trying to create a perfect cube for the number and the variable. So again, our powers have to add up to be 3. So since we already have 2 y's, I only need 1 more. And then for my numbers, so again, I'm going to grab my cards here. So we're looking for one of these numbers. So we have to decide if we can take 5 times something to get 8, which we can't. We can't take anything times 5 to get 27. We can't take anything times 5 to get 64. But we can take 25 times 5 to get 125. So that's the number that we're going to pick. And then whatever we multiply to the denominator, we have to multiply that same thing to the numerator. And then we just simplify as much as we can. So 7 times 25 is going to be 175. Okay, so we're going to have the cubed root of 175 xy in the numerator. And then 5 times 25 is 125. And then we'll have y cubed. And then we'll just simplify. So a perfect cube does not divide into 175, so the numerator is going to stay the same. So the cubed root of 175 xy divided by cubed root of 125 is 5, and then 3 divided by 3 is 1. So we'll have y to the first. So this is our final simplified answer. All right, next one. So again, we want to simplify our fraction if we can. So 162 is divisible by 6 evenly. So that is going to give us 27. And then we can also simplify our variables. So if I take 3 minus 1, that'll be 2. So in the denominator, we'll have a squared. These are both still in the radical. So our a squared, square root of a squared, can be simplified to a. And then we can split 27 as 9 and 3. So then the square root of 27 will reduce to 3 square root of 3. And we don't have a radical in the denominator for this problem, so this is going to be our final simplified answer. All right, next problem. So again, looking at this, it looks like we are able to simplify. So the square root of 9 is 3. And then for b to the 5th, we can split this as b to the 4th and then b to the 1st. So now the square root of b to the 4th will be b squared. And then b to the 1st is going to stay on the inside of the radical. Now we still have a radical in the denominator, so we are going to have to rationalize. So we're trying to create a perfect square, so I'm just going to multiply by the square root of b to the top and bottom. So in the numerator, this will become 3 square root of b. And then in our denominator, we have b squared times the square root of b squared. So now this is going to simplify to be b, and because we already have a b squared there, we're still multiplying those together. So our final answer for this one will be 3 square root of b divided by b cubed. Our last example for this section. So we can't simplify our fraction. This time we are trying to create a perfect fifth. Okay. So for the numbers, again, we're going to grab our list here. So we're looking at perfect fifths. So 32 is our smallest one. So we need to decide if we can take something times 4 to get 32, which we can. We can multiply by 8. And then since we have 1y, we need 4 more to create a perfect fifth. So we're going to multiply by the 5th root of 8y to the 4th. And then we're just going to simplify as much as possible. So 3 times 8 is 24. And then we'll have y to the 4th, still in our 5th root. And then in the denominator, so again, 4 times 8 is 32. So we'll have the 5th root of 32. And then y times y to the 4th is y to the 5th. And then we simplify. So the numerator can't be simplified. So we'll have the 5th root of 24y to the 4th over 5th root of 32 is 2. And then 5 divided by 5 is 1. So this will be y to the 1st. And that will be our final simplified answer.